So, continuing from the last lecture, talking about more about amygdala. I am not fixated on amygdala, but still because it seems to be the. So, this is like a schematic model of how hormonal systems can modulate memories. So, it is all connected. Now, if you just take a step back and think from where we started with the body and the, the mind and the structure and the networks and the synapse, sympathetic, parasympathetic system, it is all connected. Body is under control of mind. So, just look at it. Amygdala, which controls norepinephrine, acetylcholine, GABA, experience, memory storage, hormonal system, this is all connected. And we have enough proof now by modulating it with chemicals and with even people who have had lesions about the way this whole complex of amygdala manages the emotional response on one hand to external stimuli by comparing it through emotional and verbal memory. This is one part of the emotional system. The second part, why do we do things which we do? Now, sociologically it may become a problem if we try to prove everything is under chemical and electrical control, then nobody has a responsibility of any behavior. But that is a social problem on one hand, then all courts and law and morality will go haywire. But on the other hand, we also have proof that people who keep doing all these things, and it all started from studies of drug addiction, dependence, antisocial behavior. But if you look at it, just for a minute break away from yourself and observe it, don't we do things again and again which give us a kick? We feel pleasure, even if it means you want to do mathematics. So, why does not everybody do mathematics? Because mathematics is giving pleasure to somebody, or painting may be giving pleasure to somebody, or for that surfer who just takes the surfer boards and waits for on the Gold Coast for just one wave to come, or the footballer, you strive hours and hours just for one goal which you have to do. What is this? Is this will? Why could Mahatma Gandhi walk 348 kilometers at the age of 61, 12 hours a day? See, this is the translational problem in the world, where neuroscience has to unite with the world, with the behavior. What was his purpose? His purpose was to defy the law. He found out a way which was very tough on his body, and it was not one go. If you want to kill, assassinate, you go and fire a bullet. You make a lot of planning may go in, but still it's a one-off act. Walking 12 hours a day for 24 days is not a one-off act. You have to constantly keep your mind into that state. Why do people who have one leg go on to Mount Everest? On the other hand, why does somebody doesn't stop taking brown sugar? When somebody knows that alcohol is damaging or drugs are damaging, why? But if we talk on this, man's thinking will disappear, then you are a slave of chemicals actually. All emotional behavior, all behavior actually occurs in response to rewards or punishment, positive reinforcement. If you give a positive reinforcement to anybody, or somebody takes suppose some chemical and feels good, the chances are your brain will ask for it again. Now, if somebody takes something and starts feeling fearful and all, chances are that person will not take that thing again. So, it is always when you train kids, if you give them some praise and all, they will do it again and again. If you give them punishment, punishment may not always work, but if you take away something from that, then they may too. So, negative rewards are less effective then positive reward, but nevertheless, how do they do it? So, just you can go through this experiment. So, these are actually the brain stimulation activates neurons in the ventral tegmental area. This is called VTA. Again, this is we have reached the structure thing. These are midbrain dopamine neurons. If you remember dopaminergic, which have extension to that form again mesolimbic, stimulating these neurons leads to dopamine release. Rats will often choose self-stimulation over food and sex. This is a electrical self-stimulation. Every time it presses, small electrical self-stimulation was going, and there was food available, there was sex available, but rats would do electrical self-stimulation. You see a lot of kids, they will put the fingers like this in front of sun and do this, or a lot of kids will go round, spin and spin. It just gives a kick to them. The whole kick is that because with this activity, dopamine is getting secreted in ventral tegmental area, and that gives them a sense of kick, and that is what you are looking for. It is a positive reward, you are feeling a reward. So, what do? They recorded from the neurons when monkeys were performing tasks. Visual stimuli predicted the rewards. So, this is the type of firing which happens in the ventral tegmental. They provide a learning signal that every time you do a certain act, you actually get a reward, right? And so, the trick of the brain is that if you do an act, you get a reward, you are anticipating an act, expecting the same reward, but that difference is, suppose if you keep varying the reward, then the brain will judge it. The brain will judge it. It is not that brain will say, okay, fine, I have got 2 units, next act should get me 2 units, but if you give 1.99, the brain will judge it. That is the source of addiction, because every time brain wants that much. If you do not give, it will have to increase the dose of it. Okay. So, you see how tricky the whole computation business in it. So, this is why what the basis of addiction is. Lot of these drugs, cocaine, amphetamines, they increase dopamine release, especially in this area called nucleus accumbens. Now, nucleus accumbens, this when it receives dopaminergic input from midbrain and projects to the hypothalamus, both drugs appear to work by blocking the dopamine transporter for this. So, reuptake means a certain amount of dopamine is released. The presynaptic neurons, like this is a presynaptic neuron, this is a postsynaptic neuron. Dopamine is released here in the synapse, some of it is taken back by the presynaptic. So, what do cocaine and amphetamine do? They block this. So, a lot of dopamine available here. The lot of dopamine means lot of firing in that nucleus accumbens, which keeps giving a sense of kick. So, they are the primary locations for core pleasure. So, if whatever act you do, if you are actually having pleasure in that, the areas which actually get excited are this: reward seeking in nucleus accumbens. Now, I showed you that ring which was there. There is something called anterior cingulate cortex and orbitofrontal cortex, the part of the cortex. This navigates between the reward and consequences. Like if you are doing, your mind will tell you, oh, you know this is wrong. So, even if you are getting a reward, your higher center, that is the morality actually. Suppose you get a brain damage, there you do not have this part of the brain which is controlling, everybody will keep doing things which gives them reward and lot of happiness and all that. But your higher centers will keep assessing your reward, but the consequences of that also. If you take a drug, you know what is happening. But if anterior cingulate gyrus is damaged, this capacity to judge, is diminished. Especially if you see there are people who have who do lot of this solvent abuse, solvents which you find on petrol pump, they get into this brain damage, where the consequence of their behavior, the brain is not able to judge, and hence they may appear as totally facile and totally loose cannons, which you will say that the person is not having a morality, but it is actually the anterior cingulate gyrus which is not. So, what is it? It is the last sentence which is written here. Between the reward of act and the punishment of act. If we actually boil down to this as everybody is doing because of this, these are the biological underpinnings of it, then I do not think there is any criminal, but we can't do this. So, obviously, either we have to prove that they are brain damaged, and that is why they have done. So, a lot of this investigative agencies in the world have a behavioral psychology section, because if it is a brain damage thing, then the legal course is different. But if it is not, if the person knows it in its full competence and then acts upon it, then it is a different issue altogether. So, this tussle between biology and, so the important thing is, even after you are doing things again and again, your mind still can get habituated, because it is like neurotransmitter is added, you do certain thing, excess has to go off, but brain will keep trying. So, but the same amount of neurotransmitters will not produce same amount of response, because brain cannot keep going high and high. After every act, it has to come down to what you call, see, I told you once word which is called survival. Brain networks first act for survival. The second act of brain is homeostasis. Homeostasis is bringing the whole thing to a status quo. So, even if there are perturbations in the brain, even if you send a signal, the brain will always try to bring it back to the balanced state. Chemical disturbance, bring it back. When this homeostatic part of the brain actually gets destroyed, that is the point of time when a lot of illnesses and everything starts jumping. So, as I said, nicotine and cocaine modulate self-stimulation behavior. This we can. Now, this is a reward circuitry. Again, as I told you, this area, ventral tegmental area, this is self-stimulation, and these are the drugs, amphetamine, cocaine, opiates, trihydrocannabinol, which is a part of what you take, ganja and bhang and cannabis, phencyclidine, ketamine. Here you can see opioids, probably alcohol. Alcohol seems to have a different mechanism in the brain than rest of the drugs, but probably it works there. Barbiturates, benzodiazepines, which is a common drug of prescription and abuse, like alprazolam, clonazepam. They work through GABA, but they all actually, why do people become addict? Because they take it, they feel pleasure, they take it more. After some time, the same dose stops working, you have to increase the dose, but different drugs can intervene at. Now, briefly, something about the basis of this is gender and sexuality. There is a lot of fight around it right from the time when the human mind was conceived. But what biological basis do we have? We have locus coeruleus. Like dopaminergic system, we had norepinephrine and serotonergic. So, probably these are the centers. See, again there are projections here. So, right, and we know about the inhibitory neurons. These serotonergic system, they actually control your sexual urge under control. The hypothalamus, again I told you, it is involved in mate selection and recognition. Oxytocin is a hormone which is released during sexual activity. Oxytocin incidentally is also a hormone which increases the warmth and maternal bonding. So, when in the fetus around in the amniotic fluid, the level of oxytocin also acts towards this bonding. In fact, there is a nasal spray which is being formed that, okay, once you put it, a lot of empathy and warmth will flow in. I do not know whether it will work or not, but these type of experiments keep happening. Because if it happens, then a lot of fight and rage can be almost decimated. Forebrain region, amygdala again, they are strongly activated when during the physical part of the sex. Now, see this, prefrontal cortex is the one which decides, which controls decision making. The blood flow decreases in prefrontal lobe when people are involved in sexual activity. So, lot of it is actually under your chemical control. Now, whether will, your morality, your decision making, your situational thing can actually control it, yes and no. We do not know. The big question why I am mentioning this will highlight what is happening in the world. Go through the history of human race. The whole fight has been for all these things, for food, for land, for sex, for women, for men. People have been acting, if you look at history, you normally do not read history when people were living in peaceful times, when they were having harmony, when they were developing science or art and all. All history is a record of violence on a very, very broad basis. And violence is just a reflection of emotion. So, the big question is, do people act through emotional flow, or rationality is just for the time when things are peaceful? In the moment of crisis, is the emotions which actually, right from an individual to nations, is the emotions which overflow. Although on the surface it all appears that people are thinking and talking. Similarly with sexuality, with lot of sexual crimes here and there, where people are the brain damaged. Now, if you do a MRI for them, you may really not find a brain damage, but maybe later, 10 years later, 20 years later, when we are able to really describe brain in the sense of computational networking power, or really bring out some new physics to understand that, are we going to tell them that they are okay, their anterior cingulate gyrus network is transformed, like we are not able to tell about autism right now, but we know that there is a problem with the network. Dyslexia we do not know. So, that is the translational problem. The translational problem is when we talk of behavior and try to do something to help these people, we have no connection except for when we are giving drugs. We have no connection with what is happening in the brain. We do not know what is happening in the brain. Maybe someday we know that okay, this is the network problem, and I am not saying it is all network, because right now we are talking in terms of network, but maybe 10 years later we will be talking something else. We have talked about brain with quantum physics, with nonlinear dynamics, with graph theory, with network, with Hamiltonian states, with what not, computers, but we still do not have a comprehensive theory. We still do not have equations of the brain, and this is a surprise, because in psychiatry what we do, we prescribe medication. We know about some grossly the gross balance of various neurotransmitters and how they really affect. We have made synthetic chemicals which go and alter that. We have some gross data about how they alter. We still do not fully understand that, whatever our claims may be. Grossly we know, okay, we give a SSRI, it will block the serotonin reuptake, which will increase the serotonin level, which will decrease the firing. This is what is happening inside. What happens in the behavior, we observe in states of illness, give medicine. So, we have corroborative evidence, like MRI signal and PET signals are indirect evidence. We have corroborative evidence of behavior, illness with medication and their effect. Now, having said this, whatever interventions we do with behavior, psychological or training wise, or maybe non-clinical, say meditation, or we, on one hand we do this, on the second hand we cannot directly correlate with it. We can't say, okay, fine, I am telling you this cognitive behavior therapy, it is going to alter the medial prefrontal cortex. No. or maybe we are going to give drugs which are going to pump dopamine. Okay, we know this much, but if we know this much, why don't we go and change the VTN nucleus accumbens to stop drug addiction? We cannot, because we do not know the full import of it. What we have seen, that if you give this on MRI, on functional MRI, or maybe some, this is all correlative, corroborative evidence of the brain, and that is the problem. So, the big questions still remain, whether when sex is an altered state of mind, there is a good chance, because of your whole prefrontal lobe, which is deciding and giving you, guiding you morality and decision making, along with the anterior cingulate gyrus, is hypoactivated during all this activity. Then it is altered state, you are not deciding. What happens in illnesses? So, in illnesses also you cannot decide, you are in a different world altogether. If we are able to really define the whole brain functioning through these things, I am sure in next 20 years the whole definition of illness and normalcy, everything will change. So, what is happening? Behavioral correlation between, now see the commonality. Love is a normal state or abnormal state? Somebody said love is the normal physiological state nearest to madness. Now you see, I'll just see, this is very interesting, because all unless your knowledge is placed in the real context is useless. When sex, love, drugs, see what all is happening there. The attention and focus shifts. You are in love, you are really lost into different one. No, you will not listen to anything. Searching, wanting, you always keep hunting for these things. Preoccupation. When people are really in love, you ask them, whether they are working or studying, their mind is all the time with their partner, looking, hunting, restless, excessive wakefulness, sleepiness, we know. We know these are all Devdas symptoms, with climactic, ignoring negative effects. And you know what all has happened in love? Sons fight with their father, daughters run away, all sorts of drama goes on. And if you can't get, man, you have depression, angst, anxiety, fantasy, all these three, four things, and you combine this, another situation, when you have put your stake onto one ambition, that I want this, and suppose you don't get, you get into all these things. This is the problem. The firing of the brain, the electrical activity of the brain, the chemistry of the brain is, we have not been able to find specific things, that okay, this is for drug, this is for sex. Similar behavioral problems happen in hundreds of states. I have just written these three things, but lot of these things can happen if you have a loss in your life, or if you have put your stake, okay, I want admission in this college, I want to get so many marks, and you really don't get. But what we know, that in love what happens is that certain chemicals change, and the reward centers keep firing. But over 2 or 3 years, these chemicals come back to normalcy. So, love in the true energetic state does not last for long. Now, people get married during that time or separate during that time, that is a different issue altogether. So, this is the type of state which we have seen. The emotion areas like insula and anterior cortex were shown to be, sorry for the spelling mistake, it has to be shown to be active in similar studies. So, is it a changing state of mind? Because then again come back to translational thing. Lot of people, when they do love marriages and they live together, and after some years say, you are not like before, and you used to love me so much. That is the common thing in the marriage. And other person will say, no, I am like that, and so that's a show, and you can't show, obviously you don't love like you were loving in the initial years. The poor guy doesn't know biology. Otherwise, he would have said, boss, at that time my dopamine was surging high, my reward centers were going, now dopamine has come down. So, this is the type of stuff So, this is interesting to end with. This is a brain of a typical male. Brains in love and brains in lust do not look too much alike. When researchers showed erotic photos to people as they underwent brain scans, they found activity in the hypothalamus and amygdala area. But these area of lust were different from when you are in love. But eventually, what happens? Hypothalamus and amygdala are firing. In love, something is firing. They both eventually match because they both have elevated level of dopamines. And lots of dopamine triggers testosterone, which again raises the lust level. These are the real problems when you talk about brain. The problem is that however hard, however differentiated, so with all this at the end of 3 weeks, in the 7.5 hours, I hope you have got some idea and you are already thinking, you have questions in mind, which you should post to us, and we will try to have a panel type of discussion towards the end, when we receive a lot of questions from you. Before moving on to the 4th week, in the last 2-3 minutes, I hope you have understood, or maybe you are feeling confident now that I know where love is, how networks fire, how synapses work, and we know the whole area. MRI knows, there is a plethora of data. This area does this area does that, this area. You find EEG oscillations, your brain mouse does this, electrical stimulation, drugs work through this, anger comes from here, fear comes from there. Now try to put everything together, and everything put together false. Because when we talk of a certain task and area, at that point of time, we are not taking the whole brain into the picture. The moment we do this, then we do not know what is happening where. That is one. The second, the brain also has this capacity of linking with each other. So, if you take one behavior, you will find so disparate areas getting activated together, you will not know what is happening. Or if you take certain activation of a suppose someday we take certain activation of brain area and we just are able to linearly translate it to behavior, I am sure you will not get one behavior. Same areas will have 10 type of behaviors. So, if you go back to the first thing when I started, that we are talking at so many levels, right from microtubules where Penrose and Hameroff were telling quantum physics, to synaptic 0.5 millisecond transmission, to assembly of neurons working from 10 milliseconds to 100 milliseconds, to axon from 0.5 to 120 meters per second. You go up, there is assembly of neurons which goes into the Hebbian way of presynaptic, postsynaptic firing to make memory. Certain areas of brain secreting more dopamine to get reward and punishment. Those assemblies unite together to go to millicolumns and microcolumns, where large assemblies are sending dipole, the voltage difference and dipole current, which creates oscillation. Thalamus on the other hand is integrating and taking all differentiation and integration of information. Thalamocortical are creating this isolation which keep you awake and make you sleep, and we haven't talked about that. And then amygdala is there, which is firing its own emotional thing. Then there is a cerebellum, which has more number of cells, fine tuning the movement. There is basal ganglia which is sitting there to make decision making. How do we put it together? How do we put it together? So, in next last week lectures, we will see and we will try to put it together, and we will see the global brain states and see whether we can make some sense out of it. Thank you.